Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Muhammad Ashraf bin Raja Adnan. My metric number is V0918100063. I from Faculty of Mechanical and Manufacturing Engineering Technology. My supervisor is T.S. Amir Abdullah bin Muhammad Damuhuli. Today I will present about my final year project, which is my project title is Effect of Ice Ball Shape to the Temperature, Decreasing Rate of Ice Thermal Storage. In my slide has a problem statement, objective, scope of project, literature review, and also methodology. Introduction. Thermal energy storage system, like the temperature, place, or power system that can store heat or cool and utilize them later. Generally, the energy is converted from natural source of energy to a temperature different in the water uses during time of heavy energy demand, which is our office hour, 8 a.m. until 5 p.m. The energy of TES system is provided to a subsequent storage system that has 3 steps, which is charge, storage, and discharge, and also providing a full storage cycle. Meanwhile, thermal energy storage has 3 types, which is sensible heat storage, latent heat storage, and also thermochemical storage system. But generally, we use only 2 types, which is sensible heat storage and latent heat storage. Problem statement. Surface area for ice ball shape is small with diameter is 103 nm. Second, will explode if 2 strands and stretch when a maximum temperature is achieved. Third, develop a new size with a big area surface. Fourth, use polymer material into a new shape ice method. Here, objective project. The main aim of this research is to determine either aerogel ice ball shape can change with a new shape, which is square shape. Number 1. To develop a square shape method of ice ball into a thermal storage for temperature. 2. To compare with a heat transfer in thermal storage, which one is more better, either aerogel ice ball or square shape. Scope analysis. Design a square shape ice method with a polymer material. Increase the size of the square shape. Third, analyze the temperature between ice ball and square ice shape. Fourth, using a SolidWorks 2020 software or CATIA version 5 for simulation the heat transfer, and we add on the material in the simulation. Literature review. Ice-cooled thermal energy storage has been designed and made use of many years now, generally called an ice thermal energy storage (ITES) system, in order to efficiently comply with the need for cooling load and energy redistribution in building. ITES depends on the operator mode, either full or partial storage, storage type, and also charge and discharge property. It has 2 processes, which is the charging process and discharging process. During charging, cool glycol will surrounding the ice ball and phase change material happen, which is from liquid to solid. And during discharging, one glycol again surrounding the ice ball, but this time the phase change material is changed from solid to liquid. System operation mode has 3. The first one is charging, second discharge, and third is standby mode. For charging, glycol is distributed in a storage tank surrounding the ice ball and subsequently cooled down to ice with a lowest temperature. For discharging, during the release mode, the same solution of glycol in the storage tank around the ice ball and melt them. And during a standby mode, the chiller may be utilized a mode to immediately refresh the building without using an ice ball. Aerogel ice ball. As we can see, size diameter is 103 nm and it has 16 concave dimples with 25.4 nm for each dimple. Aerogel ice ball from high density polyethylene material, which is HDPE. As we can see, the dimple will flat out when from liquid is changed to the solid. Propylene glycol. Propylene glycol is also used for heat transfer and freeze protection properties, similar with ethylene glycol. When inhibited, this glycol also protects HVAC system against the damage from corrosion. For HVAC system, propylene is more suitable for use than ethylene glycol. Why? Because propylene has a lower toxicity. Okay. Minimum freezing point for propylene is negative 1.6 Celsius and maximum is negative 43 Celsius and can go more lower, which is negative 60 Celsius. Minimum burst point negative 2.7 Celsius and maximum is negative 53 Celsius. Methodology. A research flowchart is created to increase the efficiency of the analysis and the flowchart for doing the study. The research began with a review of the literature and followed by an examination of the methodology, finding, discussion, and conclusion. Here, with development of the product, we design the product by using SolidWorks 2020 or CATIA version 5 software. Here, my model product. So its size diameter is 9 cm times 9 cm times 9 cm. This will fill in the water to make a ice, and the material is polymer. And we design this and produce using a 3D printer. Method of testing. The first one is tank capacity. For tank capacity, is define the cooling capacity needed and suitable the material used, either concrete, plastic or steel. Sensor. Thermometer or thermocouple we use for measure the temperature of thermal storage. Time. The square shaped ice we put in the storage that contain glycol with water for 1 hour. So every 1 hour the data collection we get. Glycol ratio. With ratio 2:1 water glycol. We mix glycol with water, but water is more than glycol. So propylene glycol in 33%. Increase the glycol and water if we want decrease the temperature, if we want a lower temperature. Propylene glycol also can achieve until negative 60 Celsius. Here, formula for heat transfer. One system is brought in a contact with the other system with a low temperature, then the energy gets transferred from the particle in the first system to the second system. So there are many occasions when heat will be transferred from one object to another one. Okay. The formula is Q equal to M times C times differential temperature, where Q refers for heat transfer, M for mass, C for specific heat, and T for differential of temperature. Okay, expected result. What I expected from this result? Okay. Based on the project research, we can develop a new shape with a new surface area and more heat transfer happen. Why? When with a big surface area, so the transfer can happen in a more area. Second, we can add more glycol and water according to the temperature needed. In the other term is more glycol, so the temperature we can get is more lower. Okay, that's all for my presentation. Thank you.